This video goes over a few different popular post-processing views and hopefully will clear up any questions you may have had in the past, as well as show you how we analyze different designs in CFD. We use various post-processors at Verus, but today we will be showing you some ParaView post-processing, which is an open source post-processor. All meshing and analysis were performed in ANSYS. First post-process plot in this video is vehicle pressure coefficient plot. This is used to view the pressure quickly and easily on the vehicle's surface. Ultimately, the pressure on the vehicle's surface determines downforce, lift, drag of the vehicle. This is a very important plot and something we use on all analysis. The pressure coefficient is a dimensionless number which describes relative pressure throughout the flow field. The pressure coefficient is very commonly used in external aerodynamic cases. On the pressure coefficient plot, 0 is atmospheric pressure, 1 to 0 is higher pressure, and -1 to 0 is lower pressure. In our post-processing, it makes it easier to tell areas of high and low pressure due to the color plot. High pressure is yellow to red, while blue and purple is low pressure. Gray is atmospheric pressure, so it would be on areas of no effect on the surface of the car. We are looking at general pressure contour on the surface of the car using pressure coefficient. The low pressure is very easily seen on the bottom. Close up on the rear diffuser, you'll notice low pressure on the throat of the diffuser. You can also see low pressure on the underside of the wing. Higher pressure can be seen around simplified engine area. The dive planes have low pressure on the bottom side and around the bumper in this area. This is caused by the dive planes themselves and the relative high velocity that is around the side of the bumper. This high velocity is one of the reasons dive planes or canards, whatever you want to call them, can have high angles of attack and keep flow attached. The bottom side of the splitter is shown where it has lots of low pressure. You can see how the front diffusers affect the rest of the flow field. Now I will show you how we can use CFD post-processing to view something with real-world testing. Surface LIC, or line integral convolution, shows the flow field on the surface of the vehicle. To compare to real-world results, we would use oil flow, or what is called FlowViz. With this plot, we can understand how flow is behaving on the vehicle surface to better improve our designs. We have also used these plots to correlate our rear wing to real-world testing of FlowViz, as well as various other components on the 987. Correlating our CFD to real-world results ensures we are analyzing components accurately, our meshing quality is appropriate, and ultimately the results from CFD are accurate as well. The next plot is a velocity cut plot, which is scaled in meters per second. This is a slice plane which is taken out of the air, and color represents velocity. The black lines show the fluid direction. We can use this plot to gain information on how airflow is flowing around the vehicle. The dead water region, blue separated on the rear, can easily be seen. You can see the recirculation right around the license plate. A dead water region is pretty small because of how our diffuser improves flow behind the rear of the car. The different slice location just shows the same data but in a different location on the car. This one is 250 millimeters from the center line, while the first one was 100 millimeters from the center line. The next plot is coefficient of total pressure. This is a great way to see flow structures around the car, which are important for performance like vortices. Red in this area shows no energy from the airflow is being extracted, while blue signifies most of the airflow is being utilized, while black lines once again show the flow direction, and that's how you can also see the vortices. Two vortices can be seen from the dive planes here, and we can see how this changes downstream in the flow field. We specifically tweaked these dive planes on this car for better flow to the engine intake duct, and this is one of the ways we did that. The last type of post-processing we will look at is streamlines. This one is a pretty popular one since it makes really pretty images. The streamlines show how a vehicle would dissipate air as it drives. The streamlines are colored in velocity to see speed in different areas. The underbody streamlines are a great way to see how the underside of the car affects the air it's dissipating. Dirty air off the rear tire can easily be seen here. The height at which the streamlines go behind the car is very impressive. This shows how well the rear diffuser and rear wing are working together. Thank you for joining us on this quick video that kind of goes over our CFD post-processing. Thank you.